This example, find the exact value. Cosine of alpha minus beta, where the sine of alpha is 2/3 for alpha in quadrant 2, and cosine of beta is equal to negative 1/4 for beta in quadrant 3. Alright, notice how this one's a bit different, how it's given to you. They don't say find a cosine of 105 degrees or anything like that, okay? They're giving us this stuff. So what I'm going to do is I'm going to draw a picture of each one of these situations. Like draw a picture of alpha. Alright, what do we know about alpha? For alpha in quadrant 2. So what they mean is the terminal side of alpha is in quadrant 2. So we're going to have an angle alpha that looks like this. The terminal side of it's in quadrant number 2. Alright, now, what do we know about the angle alpha? We know that the sine of it is 2/3. So what I'm going to do here is I'm going to think about a point right here. And I'm going to drop a line down here that's perpendicular with the x-axis, okay? And I'm going to call this angle right here, this reference angle, alpha prime. Now, if the sine of alpha is 2/3, the sine of alpha prime, its reference angle, should be 2/3 as well. Now, if I look at this right triangle right here, what is the sine defined to be? Opposite over hypotenuse, right? So opposite over hypotenuse needs to be 2/3. All right, let's find this length of this side of my triangle, A here. Okay? According to my Pythagorean theorem, a squared plus b squared is equal to c squared, right? So a squared, I don't know, plus, what is b in this case? 2. 2 squared is equal to c squared, which is 3 squared, right? So that means a squared plus 4 is equal to 9. So a squared is equal to 9 minus 4, 5. So a is equal to plus or minus the square root of 5 if I take the square root of both sides, right? So what is a going to be? A is going to be basically like my x value here. So I'm going to say it's the negative square root of 5. I'm going to say a is negative square root of 5. Now, technically, a triangle can have a negative length to a side. But I'm looking at a as like how much the x is displaced, like if I were to go this far. In other words, like what is my x coordinate up here? All right. How about beta? Cosine of beta is negative 1/4 for beta in quadrant 3. So let's draw an angle beta whose terminal side is in quadrant 3. Here's my angle beta. Terminal side's in quadrant number 3. Let's do the same thing from this point right here. I'm going to draw a line like this and form a right triangle right here. Now let's go ahead and call this angle right here beta prime. So beta prime is going to have the same cosine value as beta. So the cosine of beta prime will be negative 1/4. So the cosine of beta is what? Adjacent over hypotenuse, and adjacent we'll call negative 1, and hypotenuse we'll call 4, okay? Remember, this length right here is this distance. This hypotenuse is this distance right here from the origin, so it's never going to be the negative number, but the x can be negative there. All right, let's go ahead and find the length of this side right here, b. Now think about it. If this is the point x comma y right here, b is going to be like the same as your y coordinate, right? So b is going to end up being what kind of a number right here? B will be a negative number when we find it. All right, could I use the Pythagorean theorem here to find b? Now, we're used to saying a squared plus b squared is equal to c squared and filling in values for a and c. But let me go ahead and solve for b first, okay? I can subtract a squared from both sides and say b squared is equal to c squared minus a squared, right? Or b is equal to plus or minus the square root of c squared minus a squared, right? Well, let's fill in the numbers for c and a now. So b is equal to plus or minus the square root of, c will be 4, minus, what's a in this case? Negative 1. Now we said we're going to end up with a negative for b, right? So we're going to use the negative case. That's 16 minus 1, so that's the square root of what? 15. So b is negative square root of 15. Alright, so I did all of that stuff right there. Why did I do all that stuff? Because I was looking for the cosine of alpha minus beta. So let me find this cosine of alpha minus beta. Now it doesn't matter that they're using alpha and beta right here. I could have used u and v, okay? It's just two things being subtracted right here. So if I use that identity, instead of using u and v, I use the identity with alpha and beta. What's the one for the cosine? It's the cosine of alpha times cosine of beta, right? Then we have what? Sine of alpha, sine of beta. And then if I have the cosine of two things being subtracted, what do I put in the middle here? A plus, right, according to my identity? Well, let's fill in here. What is the cosine of alpha? Look at alpha. What is the cosine of this triangle? Cosine of this triangle would be what? Negative square root of 5 over 3. Times the cosine of beta. Well, they gave us what the cosine of beta was. They said that was what? Negative 1/4. Plus the sine of alpha. Didn't they give us the sine of alpha? They said that was what? 2/3? Times the sine of beta. Well, look at beta prime here. Let's find the sine of it. How do you find the sine? Opposite over what? Hypotenuse? So that's negative square root of 15 over what? Negative square root of 15 over 4. Now let's calculate this stuff. Negative times a negative would be positive, and this gives me square root of 5 over 12. Positive times a negative gives me a negative. That gives me 2 square roots of 15 over 12. So what does this give me? Common denominator 12, and I have square root of 5 minus 2 square roots of 15 over 12. And that's really the best I can do there, because I cannot simplify that. I can't break down those radicals or anything else. Alright, let's look at our next example. Next one is, find the exact value. Find the exact value. Alright, so they want the exact value again. And we have the sine of inverse cosine of negative 1/2 plus the inverse sine of negative square root of 2 over 2. Alright, so they want me to find the exact value here. What I look at this as is the sine of two things being added together, right? Because this is some angle, right? The angle's cosine is negative 1/2, so that's just some number. This is just some number. Sine of two numbers being added, so I'm going to end up using at some point the sine of u plus v identity, okay? Here's what I'm going to do. I'm going to say, let's let that be u, and let's let this be v. So we're going to say, let u be equal to the inverse cosine of negative 1/2, and we're going to let v be equal to the inverse sine of negative square root of 2 over 2. Alright, so what am I going to have? I'm going to have this stuff that looks like the sine of u plus v then, right? Sine of u plus v. If I let this part be u, that part be v, right? Well, what's the identity I use here? sine of u times cosine of v plus cosine of u times sine of v I'm going to end up using, right? But I don't know what the cosine and the sine of u and v are. So let's come over here and let's draw some pictures of what u and v looks like. All right. So if I want to draw angle u, u is the angle whose cosine is -1/2. Remember, the angle whose cosine or the inverse cosine has a restriction where it has to be between what and what? 0 and pi, right? So where do you have an angle whose cosine is negative? That would be what? In this quadrant right here, right? Angle whose cosine is negative. I guess we could draw part of the unit circle here. Well, what angle is that going to be? Yeah, this is what? U, right? What angle is that going to be? -1/2 comma square root of 3/2, right? So what reference angle gives us those points? That would be what? Pi/3 for that reference angle, right? So what would that make u right here? That would make u 2 pi/3. Anyway, let's draw angle V here. Angle V. Angle V. V is the angle whose sine is a negative. Remember, for the inverse sine, you need to be between what? -pi/2 and pi/2. So where do I have an angle whose sine is a negative? That would be over here in this quadrant. So you want the angle whose sine is -√2/2. Whose second coordinates -√2/2. Well, which angle is this going to be? Or which reference angle is this going to be? That's going to be pi/4, right? That has that. All right, but that gives us plenty to calculate here. What's the sine of u? Go to angle u. Remember, this is cosine and this is sine, so what's the sine of angle u? √3/2, right? Times the cosine of v. Here was angle v right here, right? Technically, I guess. No. Technically, that's angle v. All right, so what is the cosine of angle v? Cosine of angle v is what? √2/2. Plus the cosine of angle u. Look at angle u. What is the cosine of it? -1/2 times what's the sine of angle v? Sine of angle v is what? -√2/2. And let's calculate. So this gives us √6/4. This will give us a plus, right? √2/4. What does that give me? √6 plus the √2 all over 4.